What does this brain or your brain have in common with the plastic bag? It's not the same color. While on the screen they look similar in size, that's not the case either. They're not made of the same material. Hmm. Well, do you see how this plastic bag has folds and creases? They were caused by it being shaped and molded and changed to fit into its environment. And you guessed it, your brain can do that too. My name is Jackie Hard. I'm a primary teacher and literacy coach at Riverside Christian College in Maryborough, Queensland. Today, we're going to be growing our brains. I'll be talking to you about the brain and how we as educators can harness its power to be molded and shaped so that we can improve our teaching and enhance our students' learning. So, today we're first going to be undertaking an intensive on what neuroplasticity is and how it relates to learning, before we'll look into how we can apply brain research that's centered around promoting neuroplasticity into our daily classroom practice. So, thanks to evolution, our brain is hardwired to survive. It's actually the biggest goal that it has. As such, brains have been formed so that they not only output exceptional computational abilities, but also so that their anatomy and function serve to be highly sensitive to environmental input, particularly in the form of social interactions. This is due to a biological mechanism called neuroplasticity. This mechanism allows our brains to adapt chemically, structurally, and functionally to the ever changing demands of its environment. So, to understand how neuroplasticity relates to learning, we first must know the basics of how the mechanism works. So, human brains consist of upward of 80 billion neurons. Each of these neurons have branches emerging from their core called dendrites, which receive information, and an axon, and at its end, synapses, which send information. Neurons communicate with each other via electrical and chemical signals. Electrical signals sent within a neuron are called action potentials. Once an action potential reaches the presynaptic neuron, neuron transmitters such as glutamate, dopamine, or acetylcholine are released before then being received by the postsynaptic neuron. When we learn, neurons in different parts of the brain communicate with each other. The more often a connection is used, the more efficient it becomes. This is due to the repeated action creating a fatty layer called the myelin sheath around the axon. This layer is what we know as white matter and acts as an insulator to help support the speed and efficiency of electrical transmission. So, neuroplasticity refers to the way our brain's wiring adapts in response to experiences and to environment. Neuroplasticity is such a hot topic in neuroscience at the moment because until fairly recently, the brain was thought to be mostly fixed after early development. However, advances in neuroimaging have since shown that the brain is much more malleable than previously thought, and it can repeatedly organize and reorganize itself throughout the duration of one's life. Science research now shows that brain development in mammals, so obviously including us humans, starts with an overproduction of cells, neurons, and synaptic connections during the fetal and early postnatal stages. Over time, these connections are refined through a process called pruning. Pruning is where unused pathways are eliminated based on lack of activity. In other words, if you don't use it, you'll lose it. This mechanism that underpins neuroplasticity are shaped by both environment and by human biology. So both nature and nurture actually impact your potential. Now, it's really important to note that neuroplasticity isn't inherently good or bad, it just simply is. Some positive things that can occur are enhanced cognitive abilities, recovery from brain injury or disease, and positive changes in behavior or emotions. However, as with everything in life, there's always another side to the coin. Neuroplasticity can also significantly contribute to addiction, chronic pain, or mental health conditions or disorders such as depression or PTSD. So, how does neuroplasticity relate to teaching and learning? Well, simply put, neuroplasticity is learning, and that's our educator's number one goal. We're likely aware of Lev Vygotsky and a construct he put forth within his sociocultural theory of learning and development, the zone of proximal development, or ZPD. Vygotsky's theory asserts that a child's cognitive development can be guided by their social interactions. The center of the model shows what students can achieve on their own. This is known as the comfort zone. The comfort zone is where the resources students can access outweigh the demands placed upon them. Students constantly working within this zone are just not being challenged effectively, which can lead to disengagement, lack of motivation, and decreased academic results. The outer ring of the model is the opposite of the previous and describes what students are not able to achieve with or without support due to an unbalance between the demands placed upon them and the supports given to them. This also leads to disengagement, lack of motivation, and decreased results. The middle zone, though, the stretch zone, is what effective teachers should aim for. This zone is where we see a balance between the demands placed upon a student and the supports given. Education research has linked positive relationships between students working within this zone of effective challenge, sometimes called a readiness or a stretch zone, and with increased academic results. Additionally, neuroscience research has also found that working within this stretch zone promotes neuroplasticity and growth. So, if we have our students working within the ZPD, why then does some of the learners in our class, still not improve or achieve at the same rate as some of their peers? Well, simply answered, brains are just not the same. Neuroplasticity is affected by experience, genetics, and epigenetics. The development of the brain is guided not only by one's basic genetic blueprint, but also by the various experiences one has throughout their life. The brain's experience with environmental events such as stress, social relationships, and sensory stimuli modify the organization of neural networks and influence the uniqueness of one's developmental trajectory. Basically, different experiences, genetic makeups, and the combination of these give rise to epigenetic changes and influence one's potential to learn different types of things. So, now, while we all have different potentials in relation to learning, it's really important to note that we can all actually learn throughout our lives, no matter what our potential. Based on these factors, though, we just can't look at learning as having a rigid start or end point. Learning simply cannot be a one size fits all approach. Students are not behind, they just don't have the knowledge base or have different knowledge bases due to the circumstances that have shaped their life up until this point. So then, what's our or teachers' job in all of this? Well, we play a crucial role in shaping students' academic, social, and emotional development. The quality of their education literally depends on the quality of our practice. To make informed teaching decisions, we must stay current with research on how the brain learns best and critically evaluate both the existing pedagogies and future pedagogies that we're using to ensure alignment. We must also understand that because learning is such a complex process influenced by so many factors, and because people are arguably more than the sum of their parts, approaching teaching and learning under a holistic framework is really essential. As stated, learning is a natural adaptive response to experience that's rooted within the brain's evolutionary drive to stay safe and survive. So, how can we structure the classroom culture and the classroom environment to support learning? Well, to stay safe, the brain constantly monitors its environment and only fully engages in learning when it feels safe and connected. Thus, the first thing is that considerations must be given to the emotional needs of our students. Research suggests that positive, low stress environments allow brain areas such as the amygdala and hippocampus to process and store information effectively, and in turn, they actually enhance cognitive function. Fostering low stress environments by building mindfulness activities, culturally responsive practice, and SEL pedagogies into classroom culture will actually then help students successfully learn. Further, facilitating a classroom culture that promotes high expectations for all students and where growth mindset practices are explicitly taught and the related skills are practiced is another way to support learning. Through challenging the biological determinist view students may have of themselves, we can actually increase their intrinsic motivation, which consequently enhances their long term academic and personal success. Research also suggests that learning environments that are aligned with and address students' biological needs, such as the need for adequate sleep, nutrition, exercise, and stress regulation, are more conducive to learning. So, by incorporating movement breaks, ensuring students eat at lunches, and supporting them to reduce stress, we can actually help their brains to grow. Now, while environmental and cultural monitoring is important in promoting neuroplasticity and learning, the way we structure learning is also really crucial. Active engagement and meaningful interactions are imperative for creating synaptic change. Teaching students in ways that are meaningful and that are supportive of neuroplasticity development means implementing principles that align with how the brain encodes, consolidates, and retrieves information. This then suggests that we should be using pedagogical approaches that promote collaboration and critical thinking if we really want to optimize our student outcomes. Furthermore, brains want to minimize threat and maximize reward. The neurotransmitter dopamine plays such an important role in reward motivated behavior. As such, motivation drivers, things that encourage dopamine production, such as utilizing novelty, providing adequate levels of challenge by teaching through the ZPD, and balancing support with autonomy, are arguably essential for learning. Moreover, the brain consolidates new information into long term memory through a series of complex processes that involve the strengthening and myelination of neural circuits. These processes, which can occur during sleep and rest periods, enable the retention of learned material over time. To encourage this process, spaced repetition, where students are given opportunities to learn skills before then revisiting them and practicing them over a period of time, is really imperative. Together, all of these strategies can create a brain friendly environment that helps support lasting learning. So, what did we do today in summary? Well, we defined the basics of what neuroplasticity is and how it relates to learning. We outlined why it's so crucial for teachers to engage in neuroeducation research and to evaluate their findings with their current or future pedagogical choices. We identified key opportunities that we can use from today and apply this neuroeducation research into our classroom environment, culture, and into our daily practice. Thank you so much for joining me and for growing your brain with me today. See ya!